This is problem number 7 from section 4.7. In this problem it says solve the rational inequality. And again, we have a rational inequality, we have some denominators here. We got to really be careful about multiplying across the inequality sign by the denominators because of the extraneous solution problem. So actually how we're going to start this problem is we're going to subtract 4 over x plus 4 to the left side. So we're going to subtract it and move it over so it's less than or equal to 0. So we end up with 1 over x minus 4 over x plus 4 less than or equal to 0. All right, our second step is I'm going to try to combine these using a common denominator. So I'm going to multiply this by x plus 4 over x plus 4 and this by x over x to get a common denominator. So I'm going to have x plus 4 over x plus 4 times 1 over x minus x over x times 4 over x plus 4 less than or equal to 0. Now you'll notice I'm just finding a common denominator between these, right? So I multiply this by x plus 4 over x plus 4 and this by x over x. This will give you x plus 4 on top over x plus 4. Now you could distribute that if you want. I'm not doing that, but feel free. Minus 4 times x on top, so that's 4x over x plus 4. Less than or equal to 0. Now I'm going to actually combine these together, right? I can actually do the subtraction because of common denominators. So I end up with x plus 4 minus 4x over x plus 4 less than or equal to 0. And now I'm going to rewrite that up here and combine the x and the negative 4x. So that's negative 3x plus 4 over x plus 4 less than or equal to 0. So my whole goal with this problem was to get this into a form where we have p of x, which is a polynomial, over q of x. Because I'm going to find boundary numbers by setting p of x on top equal to 0 and then q of x on top equal to 0 and solving them. Now, why are those boundary numbers? Well, they're boundary numbers because we're looking for something that's less than or equal to 0. When we set the top equal to 0, we're essentially finding the numbers that will make this fraction 0, which would make this inequality true. And when we set the denominator equal to 0, we're finding the numbers that actually make this thing undefined. And so it's splitting up our number line into different segments that then we can check to see if these different segments are solutions. So the idea here makes sense. We're going to set this equal to 0 and solve for x. And then we'll set this equal to 0 and solve for x here. When I do it here, I subtract the 4, so I get negative 3x equal negative 4. Divide by negative 3, I get x equals 4/3. Distribute this in here. Actually, I can just use the zero product property here. That'd be easier. So we're going to say x equals 0 or x plus 4 equals 0. Subtract the 4 and I get x equals 0 or x equal negative 4. So I have 3 boundary numbers here. I need to draw a number line. Mark smallest number to largest. And then let's pick some numbers that we're going to plug in. I'm going to plug in negative 5 because it's left of the negative 4. I'll plug in negative 1 here. I'll plug in 1 because 1 is smaller than 4/3. And then let's just plug in 5 out here. Now I'm going to use my calculator. And I'm going to use this inequality part. Technically, I could actually use this. Maybe I'll just use this one here. I just subtracted that over. We'll use that one right there. Let's see. We'll set the calculator there. All right. So I'm going to store -5 as x. Then I'm going to type in a fraction. 1 over x minus another fraction, 4 over x plus 4. Hit enter. Gave me a number larger than 0. So this area is not solutions. Now I'm going to do -1, store it as x, grab that function, -7/3, that's less than or equal to 0. So because it says less than or equal to, we're going from the root to the other root, or boundary number to the other boundary number. Now we're going to do 1, and I'm going to store it as x. Grab that equation again. I get a positive number, which is not less than or equal to 0. These don't work. 5, store it as x. And I get a negative number, so these work all the way out to infinity. So what are my solutions? Well, the solutions now run from -4 to 0, brackets on each, union 4/3 to infinity. So that is my solution set there. -4 to 0, 4/3 to infinity for this rational inequality.